Sorry. Hello, my name is Tanel Ilves. I'm from Estonia, and I'm here to speak more from the developer side of how to align INSPIRE requirements in a country. Just a quick remark, the one showstop for spatial data in Estonia has been since, I guess, 2004 or 2005. It was national GeoPortal for inside the country, and well, the data requirements were not so strict as in INSPIRE. So to align to the new requirements and new standards, Estonian Land Board took the initiative and started with the process. So the task of creating an Estonian national spatial data infrastructure for INSPIRE had a specific task of the spatial data repository to create data upload and refresh mechanisms that do not only work for one spatial data owner, but to several different data owners, to create discover and view service that would be INSPIRE compliant, and to create a second national GeoPortal that would be now turned towards EU. There's a view of the live GeoPortal. I will not do a live presentation because this is always not maybe the best idea. Everybody can search out the GeoPortal and have a look at it themselves. So the problem by creating Estonian SDI for INSPIRE was that the time was quite limited, and pre-analysis showed that timeline that we had in front of us and the amount of work were 2, if not 3 times uneven. So the budget or timeline was a lot smaller than the actual amount of work that came out during the pre-analysis. And now I'm talking a bit about how we solved this problem. So for the solution, we proposed that we combine open software together with GIS products that are more commonly used. So to use best practices and capabilities of base software, as there is a huge amount of developers back throughout all the world, and people have been using base software for ages, not to start inventing a bicycle. Secondly, that we combine the practices and base software with open source software to reduce licensing and maintenance costs, because not all functionality needs products that have high maintenance costs. For example, databases can be used in PostGIS that we also used, and thin clients for INSPIRE users can use open layers. They don't have to have any base software. And the GeoPortal is also open source. So this is now the general picture of the Estonian INSPIRE SDI, where the repository serves view services. The metadata database is for discover services, and there's an additional database for authorized users. And the view services are realized on ESRI components, and the discover services are on Conterra. So the software, the main platform is ESRI, which is base software and highly licensed. Then we use Conterra SDI monitor and security and service monitors, but also the content management software that is self-developed by Regio. So the SDI architecture could be described in the following picture, where we have the main engine of the spatial infrastructure here below, where we serve through internet view and discover services, and we have the output towards EU, the Estonian national Inspire GeoPortal. The big picture, to describe really easily what we think is quite unique, is that every spatial data owner, here described only with 2 examples, continues to work in their own way. So if somebody is using MapInfo, or if they have databases in Oracle, for example, then they continue to work in the old way. They don't have to change anything in their work procedures. All what is done with the data, so that towards EU everything looks as if all the data is Inspire compliant, or it is done in background using scripts and automated data change mechanisms. So the general repository on ESRI is a virtual database that has two-way traffic towards data owners. It refreshes once a day with new data if something is changed in the original base, and but also allows users to access the database for data change, that they can share data towards public authorities. That public authorities don't have to use the old system where all data structures are differently. So according to the work habits of any authority. But they can use now the new system where all the data is harmonized and homogenized, so they know what to expect. When we talk about data refresh mechanisms, or the background that actually serves the repository and the EU services with the harmonized Inspire data, then this is where we saw that the timeline we had in front of us was less than a year. It was almost half a year to develop all the system, to put the STI into position and to do data analysis at the same time. So we saw that we needed to win some additional months from developing time, and the decision was to use ESRI ARC models with ETL tools and toolbox with graphical design possibility in combination with Python scripts, so that on one side you have a graphical possibility to design a model which is already almost half of the documentation that you, after the project, you need to document everything. So it almost already clears everything up. And we, during the data analysis, we saw that these graphical tools, when combined with scripts, can be initiated for the initial and for the refresh mechanisms. And this is the solution. That's how we won at least 3-4 months of development time. Short example of how this looks and how it works. As you all probably know, Inspire requires the data to have history. So everything is logged. All the processes of data refresh are used as RSS feeds, but more detailed logs are stored in the database. Data is rarely deleted. Once initially uploaded into the database, data will stay there unless very urgent need is, then it can be erased. But the refresh mechanisms work as status change. So here in the example of an address going into a status of non-active, as probably it doesn't exist anymore. It works with all the data. Doesn't matter if it's vector, point, or if it's line, point, or area. And the data mechanisms are built in a way that they could be flexible for change in the future. If there are changes in the law that the spatial data has to align, then we don't have to start developing again. We can just do minor changes in the model. So for every team in the Inspire, one model was created, and one model for the upload, initial upload, and one model for the refreshing mechanisms. As I already explained, the differences in the initial upload erases everything that was before, and update just changes statuses. All the models are as ArcGIS server data services, and they are scheduled to start every day at midnight. The results are logged. The faster log via RSS works during the model. That gives prompt feedback. The more detailed log files are stored in the ArcGIS server. When we started to analyze this project together with the Estonian Land Board, we saw that the biggest problem is to create the data upload and refresh mechanisms in such a short time. Time span was principally, we started in the third quarter of 2011, and in the first quarter of 2012 everything was finished. So in about 7 months we had to build all the SDI together with the data models and to upload the data. So that's why the technical solution is based on combining base GIS and open software together with developing using graphical tools and Python scripts. It saved a huge amount of work, and when in Annex 2 and 3 there will be additional data coming from different data sources, then the model is very flexible and can be used easily to include data from soil, for example, and people in the department don't have to change anything in their data, in their working habits, because they just open a small window towards what the model is connected, and it transfers the data to a repository then. Yes. I hope that you have a lot of questions.
Thanks a lot for this presentation from Estonia. A good achievement, I would say. Do we have any questions in the audience? The last day seems to be a bit more relaxed here. I definitely have a couple of questions. I kind of always have this metadata in mind. So I was wondering, the update mechanism is for the data as such. And how do you handle, if there are major updates in the model, you probably also need some information in the metadata. How is the metadata flow organized from data producers to the central repository? Do you...
Yes, it's done the same way. The models are for both the data and for the metadata.
Okay, so it's mainly that locally there has to be the agreement or the method of working that when the data is updated, metadata is updated as well. Okay.
Yes, during the analysis, just there was an analysis of how different institutions are working. and where they store and how they store the data.
Okay.
So everything is built according to their actual work habits. And if they want to change something in their work habits, and I don't know, they will take into use a different database or a different base software, then the model will be changed accordingly.
Yeah, so it's fully automated.
Yes.
That's quite good to hear. And then we have this topic which is in the room by now, which is sharing the experience. Is Estonia, for example, cooperating with some neighboring countries? Because I know that around we hear several examples on different initiatives where member states do cooperate and exchange experience. Do you have any experience like that?
Well, as our methodics uses a lot of ESRI, really the backbone is ESRI. And just to clear that we are not reselling ESRI, and maybe the licensing policy and the prices are not really inspiring for the Inspire. But we are cooperating with Lithuania, and there is actually similar project in Russia, in the Moscow region, that is using the same ArcGIS for Inspire. And as we can share our experience in this field, and with companies who are dealing with the same methodics, we are talking. And for example, what inspired us to write the article was that Lithuania started with ArcGIS for Inspire almost a year before Estonia. But they haven't finished, and the problem is with the data upload and the refresh mechanisms. Because this can't be, from our point of view, this can't be really solved with the base software only.
So then we will look forward to their solution. Well, thanks a lot.